Assalamu alaikum warahmatullahi wabarakatuh. This is the theoretical part of experiment 1, separately excited DC generator. This is the circuit diagram of the experiment. We have the stator part and the rotor part. As we can see that here, in the stator part, we have supply going to the field coil or the stator, and we have the rotor rotating and generating voltage. We called the generated voltage E, and voltage at the terminal VT. الفولتج في نهايات الأسلاك VT والgenerated voltage في الارمتشر E. When we turn on the DC supply, IF, or a current or a field current, will go through the wire to the field coil here, creating magnetic field between the poles. When the rotor inside the area here rotates, it will generate voltage. Okay, so the IF right now will produce flux, okay, and the generated voltage is depending on the rotation and flux only, and this is constant. Now, if I connect load here, let me delete it. If I connect load here, RL, what will happen? I will have armature current and load current. The relation between them is equal, so IA equal IL. If RL increase, if I increase the load, IL by default will increase to meet the increasing of the load. So IL increase, and since IL equal IA will increase, and by default VA increase, which is IA RA. If we can simplify the circuit, this is the generated voltage, this is the armature resistance. So if the current pass through the resistance, it will generate VA, and this is VL. The terminal voltage, which is here, going to the load, equal the generated voltage minus IA RA. So if RL increase, IA by default increase, VA will increase. Since E, the generated voltage, is constant, and VA increase, we will end up with VT to be, or the value of VT to be decreased. So the graph will be like this. We will start with no load, so VT equal equal E, the generated voltage equal the terminal voltage, because we don't have any I load, because there is no load. So since we don't have load current, by default we don't have armature current, and by default we don't have the IARA, which is VA. And since we don't have this one, that means EA, we don't have this one, that means VT, or terminal voltage, equal to the generated voltage. So at the beginning they will be equal. Once I connect the circuit to a load, this one will be generated, so we will be having a drop with the increasing of the load current value. Thank you.